So we have a question on the Meselson+Stahl DNA replication, and it's telling us it could either be conservative or semi-conservative, and the rest of the question is really deciding between those two theories. Question A, what is meant by the term semi-conservative? Well, if we draw a little diagram, let's draw a little diagram to explain what we mean here. So our original DNA strand is, or DNA molecule is made from two strands. So a DNA molecule is made from two strands. And then when this gets replicated, the two strands will separate, so we'll break those hydrogen bonds between them. There we are. And nucleotides will bond to these with hydrogen bonds, and then you get new phosphodiester bonds to make the backbone, and so we'll get the new strand attaching to the template of the parent strand. So the marks here are, so each of these two strands of our original DNA molecule is used as a template to make a new DNA strand. So each strand of DNA is used as a template. That's the key word there. To make a new DNA strand. So your DNA molecule is double-stranded, and each strand is going to be used as a template. And then the second mark is really saying what we've got down here. So the new DNA molecule consists of an old original parent strand and a new strand joined together. So the new DNA molecule, so not the new DNA strand, the new DNA molecule is one old strand and one new strand. So people lost marks really confusing molecule and strand there. A bit of blurb about the actual experiment there, and there's a separate video by Miss Knights with a good description of that. But it asks to name the part of the DNA molecule which contained the 15N that they used. So if we draw a nucleotide, we've got a sugar, looks like a house. It's our pentose. Then we've got our base. Then we've got a phosphate, and then these are linked. Sugar phosphate, sugar phosphate, sugar phosphate down there. And so the bit with nitrogen is this organic nitrogenous base. So the purine or pyrimidine, adenine, thymine, cytosine, guanine. So we just need to say this bit. Base isn't quite enough. We need to say organic base or nitrogenous base. So the best word to say is nitrogenous base. Nitrogenous base. And that actually sort of really says it's got the nitrogen in. And there's the 15N. And they did this experiment in growing the bacteria and letting them divide in the new 14N medium after previously only giving them 15N, and they spun these in a centrifuge. And then we want two variables that we control in this centrifugation process. So in the centrifuge, not the original experiment, but when they're spinning these tubes that are over here, what would they need to use as kind of controlled variables? And so if we're spinning things, we go, well, how fast? So we'll spin at the same speed. And then how long do we spin them for? Well, we're going to spin them for the same duration. So spin for same time. And we could come up with other suggestions. The media here will have a kind of variable density, and so we could say the density or the concentration of this medium, this gel. We could put possibly the temperature that might affect the gel. pH is stretching it a bit too much, probably, and they've all got the same volume there. So my sympathy is if you said volume or pH, but really wanted centrifuging. So it's all about kind of spinning for the same time and at the same speed. Then we have the actual results that they obtained. So they started with 15, so everything was 15, and then completely changed them to 14, and so they had one division using 14 and then a second division using 14 and so on. The results that we've got here, if we grow just in 15 for ever and ever, then this base, this nitrogenous base, will only be made of 15 type of N. And if we look at our dotted lines there, this is the surface of the gel, and then we've got the two dotted lines for the light and heavy. So we've got everything below the heavy there. Okay, so that's all 15N. Part 1 is explain why the tubes A and B support semi-conservative replication. So we need to link these results, so just A and B, to what we've got there. And this one would be A and this one would be B. So in our answer we need to talk about tube A first, and it's quite a lot of students didn't talk about tube A at all. So we need to look at what we've got, need to use this information. So tube A is all heavy, so it's on the heavy line there, and all the 15 type of N, and we're actually going to get a mark for that. Tube B, then here we are, so it's not at the light, it's kind of halfway between the heavy and the light. So that's what we are making that point. We're saying it's a mixture of the heavy and the light. So mixture of heavy and light, or you could say instead of heavy and light you could go 15 and 14N, so a mixture of those. I'm going to give you a mark for that as well. So just really saying what you see, describing what we've got there. And then for the explanation, we're essentially saying for B what we've got here. So B must be one heavy strand and one light strand. So the DNA in B must be one heavy and one light strand. And right at the back at the beginning it gives us our two possible mechanisms. And why does this support semi-conservative? So we can make the kind of opposite point that if it was conservative, and they're actually going to give us a mark for that, so if it was conservative rather than semi-conservative, conservative, we would get kind of two bands here. We'd get a light one for stuff just DNA just made of 14, and we'd get a separate heavy one down here. So we haven't got this situation here we've got one in the middle instead. So conservative would be two bands, a light one and a heavy one. So if it was conservative, you get one heavy band and one light band, and we haven't got that. And the last thing to do is complete diagrams C and D. In the original exam that this came from, there was actually 2 marks, one for tube C and one for tube D. But to make this up to 60, we've said you need to do both jobs for 1 mark. So that's good. More work for less marks. That can only be a good thing, can't it? And so we are looking at our positions here. I've drawn the line on here. Our bands, if we're deciding it's intermediate, it needs to be bang on here. If it's on light or heavy, it needs to be in the positions that they've shown us. So this one, to follow our diagram down here, so there's our 2 green or heavy. So this is going to split. So this one splits into a green and a purple. So we split those. This one also splits into a green and a purple. And then we are only using, so green is our original 15, purple is our new 14, and we can only make our new DNA from 14. So I've got to get the 15 pen, put it to one side, and so we get that. So now we can see we've got 2 intermediates and 2 that are entirely light DNA. So that is going to be half intermediate. So here's our intermediate there. So we're going to have half there, and half is light, which is up here. So these are going to be the same size. Okay, and that would be C. And then if we did it again, I've got to go and get my green pen back again. So let's split this one up into a green and a purple. This one is a purple and a purple. This one is a green and a purple. This one is a purple and a purple. I can only use 14N, so I'm going to put my 15 green pen away. I'm going to make these double strands again. And here you can see I've got 2, the same number, 2 intermediate, and 1, 2, 3, 4, 5, 6 light. So 2 intermediate and 6 light, and that's going to be my D. So 2 intermediate and 6 light. So I've got to make my 6 band bigger than my 2 band. So I've got to make my entirely 14N bigger than my mixture nitrogen, my hybrid or my intermediate. So on the mark scheme, you've got to have it in the right position, but also you've got to show that your light is thicker than your intermediate band. It just comes from the theory down there. So quite a lot of work for 9 marks there.